When you see an image of an insect eye, you can quite often see that the lenses are not all made the same. Some of those lenses can be much, much bigger. That's particularly true in something like a robberfly or a dragonfly. This can be for two different reasons. It could be for sensitivity, or it could be for resolution. Sensitivity is easier to explain. As you double the size of a unit of the eye, it gathers 4 times the amount of light. That is fantastic. That's great if you want to see something in really dim light. You want to maximize the number of photons you're capturing. But it's also quite expensive because that unit now weighs 8 times as much. This is the adaptation that male horseflies are using. They have extra big lenses on top of their heads because they hover up near the treetops early in the morning, looking at a very dim sky, and they're looking for the female to pass overhead and go and catch her. But that's not what's happening in the case of the dragonfly or the robberfly. They're tuned for resolution. Physics sets a fundamental limit on the resolving power of a lens. If you had a really, really distant source of light, like a pinprick star, and you had an almost perfect lens, you still wouldn't get a perfect point on your image. Instead, you'd see a blurry blob surrounded by rings. This is called the airy disk, and it's a pattern that's created by diffraction. If you had 2 stars or 2 points of light that were right next to each other, you actually wouldn't be able to tell them apart because their blurry blobs would overlap, and they'd look like just one. The size of that blur is set by the wavelength of the light that you're using divided by the diameter of your optics. If you had a typical eye of, say, a blowfly, your lenses are only 20 microns across. That means that you can't separate 2 points of light that are 1.4 degrees or less apart. But if you scale those up to about 80 to 85 microns, as on the top of a dragonfly eye, suddenly you'll be able to distinguish points of light that are only 0.3 degrees apart. This is why dragonflies and robberflies are able to see really tiny gnat-like prey at great distances, meters away, and go and hunt them. The next time you see an insect eye, look for a region where those lenses get extra big. That tells you something really important to that insect. It wants to see something, or maybe someone, at either a long range, or in dim light, or with extra fine detail.